Hello students, my name is Shashank Shekhar. So let us continue with the exercise of NCERT, Chemical Kinetics chapter. Question says that the following data were obtained during the first order thermal decomposition of SO2Cl2. So it is already mentioned that it is a first order reaction and it is a decomposition of SO2Cl2 to SO2 and Cl2. Now calculate the rate of reaction when the total pressure is 0.65. It is given that PT, that is our total pressure, is 0.65 and two sets of experiments are mentioned. First says that when at time t is equals to 0, the total pressure was 0.5 and at time t is equals to 100, the total pressure is 0.6. Clear? Now we have to calculate it for 0.65. So let us calculate it. So first of all, we will try to find what is the rate law for the given, integrated rate law for the given reaction. So let us see this. So the reaction goes as SO2 Cl2 giving us SO2 plus Cl2, isn't it? Suppose initially this is pressure P, or suppose P naught. Now after it is at t is equals to 0, right? Now after time t, suppose this P naught goes from P naught to P naught minus small p, and this result in same amount of P because the equivalence is same, and same amount of Cl2. Now what will be the total pressure? It will be PT will be P naught minus P plus P plus P. This P and P will be cancelled and it will be P naught plus P. Now this is the total pressure. Now if I ask you what is the pressure of SO2Cl2 at time t, which is P naught minus P, that would be how much? So if you just write it, that is P naught minus P. So just now we have calculated the value of our P naught, okay? Or you can say P also. So in terms of anyone, you can do it. So suppose I am doing it in terms of P, right? So that would give you P is equals to P naught minus PT. P is equals to P naught minus PT. This will be PT. So this is the total pressure, right? So we can say, so what we have done here is that we have just calculated PT in terms of P naught and P, okay, right? Now we have just what we have done at last, we have substituted this P naught plus P by, sorry, P naught minus P by the value, this value, okay? So P will be equals to PT minus P naught. P will be equals to PT minus P naught. This is wrong. P will be equals to PT minus P naught. That would give you or 2 P naught minus PT. So this is our concentration as time t. Now can we write the rate law? Yes, we can write. It is first order reaction, so that would be T is equals to, or K is equals to 1 by T ln. Initial pressure was P naught, we have seen it. Final pressure we have calculated P naught minus P, that is equals to 2 P naught minus PT. 2 P naught minus PT. Now what we have to calculate? We have to calculate the rate when the total pressure is 0.65. So we have to calculate when this is 0.65, the time we have to calculate. So first of all, for that we would need K. Okay, we will need K here. How we will calculate K? How we will calculate K? So for that, let us take this equation. This equation, that is this information that is given here to calculate K. So let us see how we can do it. So first of all, we have calculated PT and hence P. Therefore, we have just substituted it and we got this. Now at time t is equals to 100 seconds, it is given that our 0.5 is this much and 0.5 minus 0.6 after time t. So at initial time, it was 0.5, okay? After time 100 seconds, so we put this 100 second here, we got it as this much. Our P total as 0.6. The initial pressure is this much only, right? So we calculated K from here. Now, as soon as we calculate K from here, then we can use again the same formula to calculate our rate. So this is our K value, and we have to calculate when the pressure is 0.35 atm. Okay, when the total pressure is how much? 0.65. Therefore, our pressure of SOCl2 would be P0 minus P, which is 0.5 minus 0.5 minus 0.15, which is coming from here. You can see the calculation. So we know that P total is given as 0.65. P0 is not known, but we can calculate it. So P will be equals to 0.65 minus P0. So P0 was initially 0.5. We have seen this. So that this is the value of our P. Now P0 minus P will be P SOCl2. So according to the equation that we have seen right now, the pressure of SOCl2 was P0 minus P, that is 0.5 minus 0.15. So this will be the pressure of SOCl2, and that is we need for our rate expression. So we have put all these values and got this value as 7.8 into 10 to the power minus 4 atm per second. Clear? Next question. The rate constant for the decomposition of N2O5 at different temperature is given below. So we have different temperature, and for different temperature we have different K value. Now note this unit. So it is in terms of 10 to the power 5. So if you want to ask that what is the actual value of this K, then it is this much into 10 to the power minus 5, this much into 10 to the power minus 5, sorry, plus 5. Okay, this much into 10 to the power 5. So this is the actual value of K. Now what is being asked? So first of all, we have to draw a graph between K and 1 by T. K and 1 by T, and calculate A and EA. So the plot you can this plot you can just put the values and calculate. So basically it's the graph between ln K and 1 by T. So ln K, how will calculate? Multiplied by 10 to the power 5. Put ln before this, you will get your ln K. So here it is given, and 1 by T would be reciprocal of this. So once you got 1 by T, you got ln K, just plot it, you will get this graph. Now what is being asked in the question, that is important. So it is being asked that we have to calculate the values of A. How you will calculate the value of A? For that we know the formula of Rn here, that is K is equals to AE to the power minus EA by RT. We know this formula, very clear. Now if we take ln on both sides, that would give us ln A plus ln B, that is ln A plus ln B, because it is, if we take ln on both sides, then this will be nothing but ln A into B. So we can just expand this ln A plus ln B. Now what is B here? Ln E to the power minus EA by RT. Now this can be just changed to minus EA by RT ln E, because ln A to the power x is nothing but x ln A. So these are some properties of logarithm you should know. Okay, you should know. Now ln E is 1. Now what was the graph? So if we just take it as y, this as mx, and this as c. So y will be how much? ln K. And x is how much? According to the plot, it is nothing but 1 by T. So we have plotted this graph only, na? So this is equation of line, equation of straight line. Y is equals to mx plus c. So y is this much, this is this much, right? Now what would be A? It is asked that what is A. So A will be nothing but an intercept. Okay, that would be your intercept. So here you can see this one will be the intercept. So whatever be this value, suppose this comes as x, so that will be your ln A. What will be your A then? A will be e to the power that intercept. So you just extrapolate this line further, take your scale, extrapolate it wherever it cuts this line, this y-axis, that will be your ln A value, your intercept. This is your intercept. This is called as intercept. Next thing, what it is asked? Next thing, it is asked to calculate EA. What we have to calculate? We have to calculate EA. So what will be EA? So you can see here that M is equals to slope is equals to, from this equation, it is minus EA by R. This will be your slope. Now what is, how we can calculate slope? How will calculate slope? That will be dx by dy. That is change in 1 by t, dy by dx, that is change in dln k by change in x, that is d1t. So you will just, what you will do here, so you will take your 1 by t value here, that is 1 by t value is this one, and subtract it from here, right? So you will get the difference, and similarly you will take out dln k, so final minus initial. So that would give you the slope, and that is nothing but your EA by R. But that is your EA by R. Suppose this value, upon subtracting this and this and dividing by subtraction of this and this, gives you Y. Then your EA will be minus Y into R. Got it? Let us see the solution. So first of all, the slope of the line, that is y2 minus y1 by x2 minus x1, that is your 1.12.301. Now slope is minus EA by R. So EA is equals to minus slope into R, as I have told you right now. Next is temperature is given, ln k is given, EA by R value is known. You can calculate ln A from here also or from the graph also. What is the next question that is being asked? The next question, it is said that we have to predict the rate constant at 30 degrees Celsius and 50 degrees Celsius. So we have to, what we have to do? We have to predict it at 50 degrees Celsius and 30 degrees Celsius. So how we will calculate? So for that, we will use our Arrhenius equation. What is Arrhenius equation? How we will calculate it using our Arrhenius equation? Okay. So our formula goes as ln k is equals to ln A minus EA by RT. This is the formula. Now if I write it for two different temperatures, then it would be, suppose if I am writing at T1, at which our rate constant is K1, therefore the equation will become ln A. Now this is very important to notice here that temperature will neither change EA nor change ln A. They both will be same. Okay, so this will not change. So ln A minus EA by RT1, isn't it? Similarly, for temperature T2, it will be ln K2, ln A minus EA by RT2. Now, once we got these two equations, and we know the value of our ln K1 at a given temp 1 by T1 value. So if you subtract both of these equations, so I'm subtracting 2 minus 1. So what you will get? You will get ln K2 by K1. If you subtract both of this, then this ln A and ln A will cancel out, and you will get EA by R 1 by T1 minus 1 by T2. You know the value of K2. Sorry, you have to calculate the value of K2. You know the value of K1 because it is given. We know EA is, we have calculated just right now. T1 we know, T2 we know. Just put all the values, get your ln all these values. Now once suppose you have done all the calculation and got it as A, then how you will get K2? So take ln on anti-logarithm on both sides, that would give you K2 by K1 is equals to E to the power A. Therefore K2 will be equals to EA into K1. Your final answer. Next question. The rate constant for the decomposition of hydrocarbon is this much. So this is our rate constant. K is given 2.418 into 10 to the power minus 5. And that is at temperature 546 Kelvin. Now calculate the energy of activation. So if the energy of activation is given, the energy of activation is given, EA is given 179 0.9 kilojoule per mole. This is given. So we have to calculate the value of pre-exponential factor. So if I ask you, this is our RNS equation. If I ask you that what is in all of these terms, which is RNS factor? So clearly this one be a RNS factor. How I will calculate it? A will be equals to K e to the power minus EA by RT. This would be your formula. Now what are the values that are given? Let us put all those. So 2.418 into 10 to the power minus 5. 2.418 into 10 to the power minus 5, that is the K value. E to the power minus EA value is given 179.9. 179.9 kilojoule per mole. So I would suggest you to convert this kilojoule per mole into joule per mole. Joule per what is the value of R? 8.314 joule per mole per Kelvin. Now I would suggest you to cancel out the unit, okay, by yourself. And temperature is given as 546 Kelvin. So this E power should be dimensionless. Kelvin and Kelvin get cancelled. Joule per mole and joule per mole and joule per mole gets cancelled. And this is nothing but your per second. So using this, you can calculate a pre-exponential factor. If you use this equation, you can calculate a pre-exponential So let us see the solution for this. So K is given, T is given, EA is given. Put just all the values. You can just expand it also, or you can use in the way you can solve in the way I told you. You can solve in both ways, right? Now, next question. What does it say? Consider a certain rate A, which is going to be with rate constant this much. Calculate the concentration of A after 100 seconds if the initial concentration is this. Now you would say, sir, we are not given with the rate order of reaction. How will solve the question? So see, students, here we get fooled because the rate constant is given along with its unit, and the unit is clearly shouting that it is a first order reaction. It is a first order reaction. It is clearly shouting. So you will simply apply the first order rate law. So what we have K. So if you write, we have K, that is 2.0 into 10 to the power minus 2. K is equals to 1 by T. It is given as 100 seconds. Ln initial concentration is 1. What will the final concentration? We have to calculate. Just multiply this 100. That would cancel out this and give you ln 1 by A at time T is equals to 2. Or we can write it in this way, that minus ln A is equals to 2. We can write it, no problem. So here, from here, you can calculate the value of AT. Just take anti-logarithm e to the power minus 2. That would give you concentration for time T. Clear? So let us see the solution. So we have done the same thing. We have used the formula, just solved it to get our value of concentration at time T. After that, question says sucrose decomposes in acidic solution into glucose and fructose. According to the first order rate law, T half is equals to 3.00. What fraction of sample of sucrose remains after 8 hours? So since it is given that it is first order, therefore K will be nothing but 0.693 by T half, which is 3.00. That would give you 0.231 per second. Now we have to calculate what fraction of sucrose remains after 8 hours. So it is 8. So K is equals to, we know the integrated rate law. K is equals to 1 by T ln initial concentration. Suppose I am representing it by A naught by 80. You have to calculate what fraction is remaining. Okay, so you will calculate 80 by A naught, not A naught by 80. So that would be, if you just cross multiply it, you will get 1 by 8 into 2.31, or we can write it as how much? Ln, sorry, 80 by A naught is equals to e to the power 1 by 8.231. Just calculate this thing, you will get a fraction of consumption of your sucrose. So you have to do the same thing, R naught by R. Therefore, you can calculate it as 0.231 hour from here. Now you have to calculate not R naught by R by R naught. As I have told you, that would be 0.1576 or 0.158 approximately. After that, the decomposition of hydrocarbon follows the equation this one. K is equals to 4.5 in 10 to the power 11 per second. Now this is clearly your A because it has the unit of exponential factor. Next, what it is given? This is given 28000 K by R. So how will calculate this? So we know that this is nothing but 2800 is nothing but minus EA by 2R. EA by R. Just calculate this thing. Okay, put the value of R as 8.314. You will get the value of EA from here. Let us see the solution. So this is given. We just compare it with this equation, that would give us this much. We got EA is equals to R into 28,000 Kelvin. That is 232.792. The rate constant for a first order decomposition. So we have a rate constant for a first order decomposition, and it is given by the following equation. Okay, it is given by the following equation. Calculate EA for this reaction and at what temperature is half-life period is 256 minutes. First of all, let us calculate EA. So I will calculate this EA. So this is nothing but our Arrhenius equation. If you compare it with the Arrhenius equation, that says that ln A minus EA by RT, this is our equation. Now EA by RT will be equals to 1.25 into 10 to the power 4 K divided by K divided by T. So T and T cancelled out. R value we know 8.314. This will give you an EA. Now once you got your EA, you will be able to calculate say your temperature. Okay, you have to calculate its, you will be able to calculate its temperature. And further, so at what temperature will it be? Half period will be 256 minutes. So it is given that, so you can't calculate temperature because two are unknown. Temperature is unknown and log K is unknown, so you cannot calculate. Now it is given that half-life period is 256 minutes, and since it is a first order reaction, therefore K will be equals to 0.693 by 256. Okay, now next, so once we got this thing, so you will just equate it with 1 by, sorry, ln A, whose value is given 14.34 minus 1.25 into 10 to the power 4, 1.25 into 10 to the power 4 Kelvin by T. You just solve this equation to get the value of T. Let us see the solution. So we have this. We compared it with this one. We got EA. Very easy. That is 239.34. And we have T half. We use it to find our K. And this is our K. Now you put all these values here. Okay. Log 1 for 4.14. You calculate T from here. That would give you 668.95 Kelvin. Next question. The decomposition of A into product has value of K as this much. Okay. And energy of activation is this much. At what temperature K would be 1.5? So you will simply use this formula. We have K2 4.5 into 10 to the power 3. K1 we have to calculate. Energy of activation is given 60 into 10 to the power 3. I'm writing it in Joule by R 8.314. Okay, 1 by T1. So T1 is 10 degree. Right? T1 is 10, no, T2 is 10 degree. Sorry, T1 is 10 degree. So that would be, sorry, we have taken this as K2. So this will be T2. This will be T2. Now T1 we have to calculate. So 1 minus 10. That would bring us to this K1 value. K1 value is given 1.5 into 10 to the power 3, 4. And this cancel 15 3 45, 0.3. ln 0.3. This multiplied by 8.314, 16 to 10 to the power 3, 1 by T1, and this will be added to 1 by 10. So this much plus 1 by 10. That will be 1 by T1. Just cross multiply to get the value of T. Clear? Let us see the solution. Solution says that from Arrhenius equation, we obtained this equation. We perform this to get our value of T2 in Kelvin. If you want, you can calculate it in degrees Celsius also. Just subtract 273, 3 7 minus 3 4, 9 minus 7 2, 24 degrees Celsius. After that, at time of 10 completion, the time required for 10 completion, 10% completion, so this will be 10% completion, not 10 completion, of a first order reaction is equals to that of time required for 25% completion. So this question has says that for 10% completion of a first order reaction at 298 Kelvin, okay, is equals to that time which is required for 25% completion at 308 Kelvin. So this is being said. Now the value of A is given. Calculate K at 318 Kelvin. We have to calculate K at 318 Kelvin, and EA also we have to calculate. It's not E3, it's EA. Now how we'll do it? How we'll solve this? So for that, we have to use our simple Arrhenius equation. So which says that K is equals to A e to the power minus EA by RT. We will use this. Okay, you will use this one, and it is being given that this K, suppose I'm saying it as K1. So this K is equal for both say Ks. Okay, suppose this is K10. I'm writing for K10 suppose. So A is given 4 into 10 to the power 10 minus EA. I will left it as it is, leave it as it is, e to the power minus RT. R and T. R is given 8.314 and T is given as 25. Sorry, 298. So for 10 completion, it is 298. Now, if you find the value of EA from here, that would be K10 divided by 4 into 10 to the power 10, and to take ln on both sides, Then this will be EA by nothing but 1 by 8.314 into 298. You will calculate EA from here and EA from the another equation. Just equate it to get a relation between K10 and K25. Once you got this, just use it to find at 318 Kelvin. Okay, let us see the solution. So first we will use T. This is our rate law. This is given. So we will use this equation, and hence you will find the ratio of K and K dash in this way also, or in that way. You can find it in either way. Now once you got this, use it in this way to get this relation here also. So two equations, sorry, two variables, two equations you got. Solve it to get the value of K and K dash. Further implied to find the value of EA and K value at the different temperature. Hence, we can find this as 1.034 into 10 to the power minus 2 as our final. Last question. The rate of a reaction quadruples. How much? It becomes 4 times when the temperature changes from 293 to 330. Calculate the energy of activation of the reaction, assuming it does not changes with temperature. Rate of reaction quadruples, so rate constant also quadruples. Okay. Suppose initially it was K1, now it becomes 4K1 at temperature T2. This will be EA by R 8.314. Okay. Now initially I have taken K1 by K2. So this will be K2 minus K1, right? So K2 is 1313 minus 1 by 293. Now you can calculate your EA from here. That would be minus ln4 multiplied by, so I'm just taking ln 1 by 4 as ln minus ln4 multiplied by 8.314. Now this and this will be multiplied. So 313 into 293 divided by 293 minus 30. So if I take minus sign out from here, then that would be 313 minus 293. This minus and minus will be cancelled. Calculate this value to get the value of EA. Now let us see the solution. So K2 by K1 is this much. It is 4K1. This get cancelled. Now you further put all the values to get the value of our EA. Now in this way you can calculate your EA. So this was for today's lecture. Thank you.